Okay, chapter 2.1 is about linear equations, solving linear equations. Okay, when you solve linear equations, we have to collect all the x terms to one side, especially to the left side of the equation, so that the equation starts with x equals something. Then the right side of this equation, this is the solution of the linear equation. So let's do some examples. Okay, this is example number 23 in the textbook, page 53. Okay, the equation is 3t plus 8 equals negative 2. Okay, already the t term, the variable term, is on the left-hand side. So we have to remove plus 8 to the right. And what we can do is the opposite of 8, positive 8, is negative 8. So we subtract 8 from each side. Then 3t equals, this one cancel out, negative 10. The left side is 3 times t. So we have to get rid of this 3, the coefficient of t, by dividing each side of the equation by the coefficient 3. Then 3 cancel out. T equals negative 10 over 3. So we just rewrote the equation so that t alone is on the left side of the equation. So this value is the solution to this equation. Okay, let's try another one. Number 31. Okay, this is 3 times x minus 4, 7x plus 6. Okay, there are variable terms on the right, 7x, and 1 inside the parentheses. So first we have to remove the parentheses by using the distributive property. So 3 times x is 3x. 3 times negative 4 is negative 12 equals 7x plus 6. Since there are 3x on one side, 7x on the other side, let's move 7x to the left by adding the opposite of 7x, which is negative 7x. So subtract 7x from each side. Then 3 minus 7 is negative 4x. Minus 12 equals, cancel out, positive 6. Okay, now do the same thing. The left-hand side has minus 12. So get rid of this minus 12 so that you will have only negative 4x on the left side of the equation. So minus 12, so the opposite is 12. So add 12 each side. Then negative 4x. Cancel out. 6 plus 12 is 18. And the left-hand side is negative 4x, negative 4 times x. So let's get rid of this negative 4. How? Divide each side by negative 4. Then negative 4 cancel out. X equals negative 18 over negative 18 over negative 4. Then we can reduce the right side of this equation. 18 is divisible by 2, so divide by 2. 4 divided by 2 is 2. So finally x equals negative. Make sure this negative sign moves to the front side. So negative 9 over 2. Okay, this is the solution. Okay, let's do an example. In this case, number 36 on page 54. Okay, the equation contains fractions t over 6 plus t over 8 equals 1. Okay, actually we don't like fractions because there are denominators. So let's first get rid of the denominators by multiplying the equation by the LCD. So I'm going to multiply the equation by the LCD to remove the denominators. Okay, then what is the LCD in this case? LCD, LCD, the least common multiple of the denominators 6 and 8 is 16? No, 24, right? 24. How do you find the LCD? LCD, which is the LCM of 6 and 8. So LCD always comes from the larger number. It's a multiple of one of the larger numbers. So multiple of 8. So there are 8, 16, 24, and so on. And let's check if 8 is a multiple of 6. 8 is not a multiple of 6. Then let's check the next multiple of 8, which is 16. And 16 is not a multiple of 6. Then we have 24. Let's check whether 24 is a multiple of 6. 24 is a multiple of 6. So the least common multiple is 24. So let's multiply the equation by 24. All right. Multiply the equation by 24. So let me put parentheses and multiply this by 24. Also multiply this one by 24. Okay, 24 is the LCD. Then we can distribute each term inside the parentheses by 24. So that will be 24 times t over 6 plus 24 times t over 8 equals 24. Then from this we can simplify. 64 divided by 6 is 4. So we have 4 times t, 4t. And 28 divided by 8, 24 divided by 8 is 3. So 3 times t is 3t equals 24. So by multiplying the equation by the LCD, we remove the denominators 6 and 8. So this equation has no denominators, no fractions. So we just combine the like terms. 4 plus 3 is 7. 7t equals 24. And remove the coefficient of t by dividing the equation by the coefficient t. Then t equals 24 over 7. Okay, this is not, we cannot simplify this, so the solution is 24 over 7. Okay, now number 45 on page 55. Okay, there are 4 y's on both sides. There are actually 2 terms on each side, so one term on each side. So let's move 4y from the right side to the left. So subtract 4y from each side. Then what happens to the left? 4y minus 4y is 0, so we have negative 3 is equal to 0. Now when you solve an equation, we should have x equals something so that we can find the value of x. But in this case, the variable y is not in this equation, and it gave us a wrong equation. This equation is false. This is negative 3 is not equal to 0. Then our conclusion is there is no solution. Okay, this means no matter what the y value is, plug in any value of y and it does not satisfy the equation. So we cannot find any y values. So so we just conclude it as there is no solution. Okay, let's try another one. Number 46. The equation is 24 minus 2x equals minus negative 2x. So there are two terms, one term on each side, on the variable term on each side. So let's remove, in this case, let's move this negative 2x from left side to the right. That means we have to add 2x each side. 2x each side. Then the left hand side has only 24. Minus 2x plus 2x becomes 0. Even the right side is also 0. This one still, the equation is false, so we can conclude it. There is no x value. So there is no solution. Okay, this equation has parentheses. So let's remove the parentheses by using the distributive property. So 4 times 2x is 8x. 4 times negative 3 is negative 12 equals 8x minus 12. Let's remove this 8x from right side to the left. So subtract 8x from each side. Then the left hand side cancel out. We have negative 12 equals the right side, 8x and minus x is 0, and negative 12. This equation does not contain the variable term x, but this equation is true. Negative 12 is equal to negative 12. This is always true. So no matter what the x value is, the equation is always true. Then we can conclude there are many solutions. There are actually infinitely many solutions. So all the x values, all real number x, can make this equation true. So there are one solutions, two solutions. No, there are infinitely many solutions. All real numbers will be the solution to this equation. So whenever we have an equation which is true, then we will conclude it as what? There are infinitely many solutions. Okay, how about the previous example? The result that we have is false, always false. Negative 3 cannot be equal to 0. Then we can conclude it as what? There are no solutions. 24 is equal to 0. This is not true. Then we say there is no solution. No x, we cannot find any x values. No real number satisfies the equation. On the other hand, if the result is true, then all real numbers, all the values of x satisfies the equation. So there are infinitely many solutions. Let's try another one. Number 48. 9x plus 6 equals 3 times 3x plus 2. Okay, let's remove the parentheses. The left hand side is the same. The right hand side, 3 times 3x is 9x. 3 times 2 is 6. Get rid of 9x from right side, so minus 9x from each side. Then cancel out, 6 equals cancel out 6. This equation is true, always true, which means there are so many solutions. There are infinitely many solutions. All real numbers are the solutions. Plug in any value of x, then the equation will be true, always true. Okay, so for this section, 2.1 is about solving linear equations. So when you solve a linear equation, there are 3 types of solutions. 3 types of solutions. 1, there's exact solution. Exact solution. So we may say x equals some value, x equals something. Number 2, there is no solution, no solution at all. When there's no solution, whenever we have an equation which is not true, something like 3 equals 2, then we will say there is no solution. We cannot find any x values in this case. Number 3, there are infinitely many solutions. When do we have infinitely many solutions? If when you solve an equation, it gives us an equation that is true. 3 equals 3 is true, 0 equals 0 is true, so 31 is equal to 31, just like this. Then we will say that there are infinitely many solutions. All the real numbers will satisfy the equation. So there are 3 types of solutions when you solve an equation.